So let's consider just single bit addition. So we're doing single bit addition, right? We've got, well, we'll make this more general. We've got a bit 1 plus, or we'll call it A. We've got A plus B, where A and B are both single bit numbers. And so we know that when we add them together, we're going to have a sum, and we're going to have a carry, which we're just going to come down and we're going to have a carry. So we've got a carry and a sum, right? So sum and our carry. Let's look at each possible situation for this, or generate a table. So really our inputs are A and B, and our outputs are C and S, or our carry and sum. Let's take a look at what we get here, and we'll call this in and out. So of course we can kind of think of this as a truth table, which in essence it is. So we know that our inputs, we just want to have every possible combination. So just count binary 0, 0, 0, 1, 1, 0, and 1, 1. There's our 4 possible combinations. And now let's think about what happens if we add 0 to 0. Well, our sum is going to be 0, and our carry is also going to be 0. If we add 0 to 1, the sum is a 1, right? The output is a 1, so that means our carry is a 0. And addition is commutative, so we know if we have 1 plus 0, it's still going to be the same as 0 plus 1. So that's the same. And finally, when you have a 1 plus a 1, right, so we got 1 here and a 1 there, we know that's 2. And 2 can't be represented with 1 bit, which means that we gotta have a carry. So that means we've got 1 here and a 0 here. So this is our kind of our final output. And it's actually pretty easy to find the functions for sum and carry. One thing that is a good idea if you haven't already is look at truth tables and work with them enough to the point where you can realize that this right here, well, just think about it. Can you see what function, what fundamental logic gate this is? It's an XOR. And this one should be easier. What function is this? Well, this is the AND function. So that means if we want to add A to B, we can take our AND gate, and we can also have our exclusive OR gate, and we can just take A and B and just feed them in there, right? So here is our carry, and here is our sum. So it's pretty easy to add 2 bits, but as you saw the title here, this is just a half adder. And the reason why we call it a half adder is, yes, we made provisions for our carry out and adding 2 input numbers, but we know that when we have multiple digit numbers, that we also have to deal with a carry in. And we did not deal with a carry in with the half adder. So that means that though the half adder is useful for exclusively single bit calculations, the moment we start dealing with multi-bit numbers, we're going to have to do a little bit more. So that's what we'll look at in the next video, is You guessed it, the full adder.